name's John. Welcome to the last in a series of videos all about welding aluminium using the spool gun. To power the spool gun, I'm going to be using this MIG 180 inverter welder. In all the previous videos, all the welding you've seen has been done using this 13 amp adapter lead. What I intend doing now is turn the welder up to see what it'll actually do on full power. To use the machine on full power, you need a 16 amp supply. So we'll remove that lead, plug the welder into my 16 amp supply. Now we can use it to its full potential. You wouldn't normally buy a welder like this to weld sort of half-inch plate like that, but it's nice to know if you have a job to finish off or a small job to do on real heavy stuff, the machine is capable of doing it. I'm going to carry on using the 1mm wire on the spool gun. The machine's designed to self-limit its performance or self-limit its amperage output on 1mm wire. So you don't want to go putting 1.2mm wire in because it could possibly damage the inverter. I'm going to set some welds up with some real thick material, try and get some shots looking for a welding visor to see how it actually welds, as well as shots of the front of the welder showing you the various settings and what amperage it's actually producing. This video is not to show you how to weld. I'm not a welder. This video is to show you what the machine's capable of doing, how to set it up and how to get the best out of it. There's plenty of people on YouTube that'll show you how to weld. At the minute I've got the wire speed set on full and I'm slowly going to increase the voltage to get to the point where the voltage overruns how much wire I can actually put out. Here I've got set up to a piece of 1/2 inch plate and a piece of 1 inch plate. They're cold, no preheat. I'm going to try and run a weld along there and then possibly do 1 or 2 tests on it. I'm going to run 1 bead along there, see how it goes. That actually is not a bad looking result. You can see how the weld's improved and it gets towards the end as the job warms up. There's a little bit of black soot on it, nothing to worry about. That's quite a decent weld. I'll weld the other side, there's some heat in it, and see what sort of difference it makes. So there is a little bit of heat in this now. Try one more run into the bottom of this weld. I'm going to increase the voltage slightly. Obviously I've got to leave the wire speed the same because it's done maxed out. Right, and to me that weld is noticeably better. I'm going to give it a little bit more voltage, but basically I think we're nearly on the limit now. One more run. It's the speed at which you can lay the weld down is the thing that amazes me. Once again, I've got some 1/2 inch alloy plate set up. I'm going to weld that bracket on and then do some practical weld testing on it. Weld it from cool. This is the piece you've just seen as well. It's actually still warm. There's several methods of testing welds. There's one method of testing a weld that gives an instant result. The trouble is, it destroys the part. It's basically a kinetic test. Right, so we'll give it some. I mean, I'm hitting that, I'm really trying. And there's no attempt at the weld to tear away. I think you get the idea that it's quite a sound weld. Right, basically that's going nowhere. This is the weld we did earlier, the real heavy block onto the 1/2 inch plate. What I'm going to do with this is cut down through it and then polish it and then put a chemical on which will actually show the weld slug to show how much weld penetration we've actually got. And the one we're just doing the kinetic test, I'll cut that one as well, polish it up, put the chemical on and see what sort of results we've achieved. Right, I've polished up the 2 test pieces. I'm just going to warm them up. Not stupid hot, just enough to take the chill off them. Right, next for that chemical treatment, the chemical I'm going to use is an oven cleaner. The active ingredient in the oven cleaner is sodium hydroxide. I'm wearing gloves, the garage is well ventilated and I've got eye protection on. You don't play with these things. Right, so we'll put some of that on and what happens is the sodium hydroxide reacts with the aluminium. It reacts with the aluminium weld, which is basically a cast metal, in a different way that will react with the aluminium parent metal, which is probably an extrusion. The grain structure will be totally different and that's why it gives a different effect on the weld metal than it does the parent metal. I've left the chemical on all night and you can see it's got a definite difference between the parent metal and the weld metal. Same on this one. Quite pleased with that result, quite a nice looking weld. Right, aye.
I touch it and come away.
Yeah. Yeah, I tell you this, that's pretty good, that bit.
One more go?
One more, we'll go a little bit slower.
A little bit slower.
Right. Right. Yeah, I'll tell you what it is. It's not bad, that.
I think it's cracking.
Then take your hat off.
Can I just put that on there?
Yeah, just put it on there. Right.
That's cracking.
You like it?
That's better than the other one.
Is it?
Yeah.
Because you can see.
Yeah.
That's aluminium MIG welding.
Go on, you Deb.
Auntie Dave.